This video shows a test sequence supported by the Titan System Program Office located at the Air Force Space and Missile Center in Los Angeles, California. Added understanding of the explosive nature of Titan SRMU propellant was provided by the 44,000-pound test. Data from the test was utilized by the Lawrence Livermore National Laboratory in developing a computer safety code needed for predicting explosiveness in missile fallback accidents on land during a spaceflight launch. A first frame with a handheld camera from 1.7 miles away showed a large fire bubble and numerous burning propellant fragments. At this time, the fire bubble was about 400 feet across. The second handheld picture shows many more burning propellant fragments. Two dark zones at the base of the expanding fire bubble were made by explosive-operated argon flash units. Continuation of the explosive event is shown in the third handheld picture. Some burning propellant fragments landed as far away as 2,000 feet.
Oh, beautiful. Oh, beautiful.
Normal 30 pictures per second video from 1.7 miles. A mushroom cloud developed as expected from a large amount of rapidly rising hot gases. Shown here is a slower video repeat of the 60-inch critical diameter test.
5, 4, 3, 2, 1, test.
Oh, beautiful. Oh, beautiful.
A second video beside the first was zoomed in to give an enlargement of the 60-inch test beginning. This is a slower speed repeat of the view from the second video camera. In this photograph, the red crew is lifting the last piece of propellant to make up the 60-inch critical diameter test sample. Here's a view of crystal pin mounts for measuring lateral expansion of the aluminum band seen at the upper left corner. A 178-pound, 1-inch thick C4 explosive booster cone for the 4,200-pound main charge is shown here. This picture shows the 4,378-pound explosive donor system being brought to the top of the 44,000-pound cylinder of SRMU propellant. Here is shown a view of the armed donor charge just before the test. Two 1.4 millisecond duration argon flash units 12,000 times brighter than the sun were fired in tandem. Each unit was powered by 105 pounds of C4 explosive. Complete ground zero experimental test system prior to the test. On the left can be seen a 4-foot diameter foam hemisphere that was used to focus a 35 gigahertz radar beam for tracking aluminum band expansion. Ground zero experimental setup exhibiting 24-foot high mirror used to provide uniform sample illumination for the high-speed cameras. Coming up is a 30 frame per second playback of 17,000 half-frame pictures per second film made by a Photech camera. This is a slower speed repeat of the 17,000 half-frame pictures per second record made by a Photech camera. An explosive front can be seen as a line traversing down the lower half of the test propellant cylinder. The moving white spot on the screen is the explosive initiation pulse passing through our noiseless trunk line system. This is the Photech film being played very slowly. Details not noticed at faster viewing rates can be observed. This is the first view of 34,000 quarter-framed pictures per second of the 60-inch critical diameter test, played at 30 frames per second. Seen here is a repeat at a slower rate of the 34,000 quarter-framed pictures per second of the 60-inch critical diameter test. The 34,000 quarter-framed pictures per second film of the 60-inch critical diameter test is being displayed at an even slower rate.